Hello, are we live? Let's see. I think we are. Right, okay, so today I want to show and do some work on, we'll see how much time we have, a project that I've been working on for PDFs. So the problem is we have a paper like this, and I'll explain why in a minute, but it's a generally interesting problem that there are loads of papers out there. In this case, these are the papers about oil and gas, amongst lots of other things, and the person who's done this has done hundreds of papers, and there are lots of other organizations who've put out papers, and if you want to find a particular graph, it's almost impossible, because if you think, I've seen a graph somewhere, where was it? Was it in this paper or in this paper? Who wrote it? When was it from? Which page? This one is only 26, but this one is 55, and lots of them are quite long. So this is the idea that we can write something to basically read through the PDF and say, here's a graph, I'll have this, put it in a database along with some metadata, for example, what the paper's name is, the year that the paper was published, all the other text on the page, the text on the graph, and then you'll be able to search them and they'll come up. And so that makes working with this data a lot easier. And there's another interesting problem, which you might have noticed, that all of the normal text on the page is in French. And if you do not speak French, or if you don't know whether in different languages, it's another interesting thing to try and translate between them, but that's more of a search problem than a sort of PDF parsing problem, which is looking at the moment. So the basic idea is that we want to try and capture this graph and then export it as an image, which we can then reference through a database. And I've built a website which you can see here. I've built something. I've built a Python script to do this, but it has some problems which I will show you. But it basically works at the moment. This is a work in progress, but it spits out a bunch of graphs along with the associated text, and if you click on them, then it jumps you to the website where the graph was, and then you can look at it, and you can put search terms in here. For example, this will give you all of the gas papers, or rather, it will give you all of the images which have gas on the page. So for example, these are pictures of wood gas cars. But it's still better than nothing. But I think if we scroll down, we shall see one of the issues. Of course, when you want to show them, you can't find any examples. Let's see, I think this was, I've also added so you can put an ampersand. Yes, we get lots of these blobs here, and on some things you search, you just have hundreds of them. And what I'm pretty sure these come from is if you look on the in the graphs themselves, you'll see these squares here, and these some of them will be images, not drawings, which we'll get onto what that means in the context of PDF. But basically, what it means is that lots of these little blobs end up getting put in when they're meaningless. So one of the next things that I'm going to do is to make it so that doesn't happen, basically. So this is the goal of the PDF parsing, but it needs to be improved quite significantly. One of the main reasons is getting that, and also I'm doing about 200 papers at the moment. I'm scraping them all from the website, and then I'm parsing them. But I would like to be able to do a lot more, to add other people's in, and to be able to, you could add your own and you can upload them and things like that. But the problem is that the Python script to do this is very slow. And I think that's partially because Python does have a tendency to be slow, especially if you're not just using it as a puppet master for C and Fortran. But also, I think the way that I'm doing this is rather inefficient. But I can't think of a better way to do it in the library that I'm using. There might be a better way. I haven't found one yet, but I'm not sure. And one of the problems is, let me try and find. So on a page like this, it can't differentiate between these. If I go over here and I try and find this. US Weekly. So you can see here, this is that graph, and you can see we have both graphs stuck together when really we'd want them to be separate. And also, interestingly enough, this is showed up in two papers, but that's not here. But you have lots of these graphs. Where you have two graphs on a single page, which is not you have 6. So it would be really good if we could split these up, but as I will show you, the way that the parsing is currently done doesn't really allow that. So that's the basic idea, to speed up the script, to get rid of the small images, and to be able to differentiate between graphs. So I think what I'll go over today is the basics of how the existing system works, and then I might start looking at how I'm planning to improve it, which is I'm going to try and do it in Rust, because Rust is fast, I like it, and there's an article that I found which I think will be helpful, and sort of looking at a lower level, because, well, Rust does most things at a lower level, but in terms of PDFs, it goes at a lower level, so I think I might be able to solve some of those problems. So, let's have a look at the Python code now. This the Python sort of has had, because originally what I did was rather convoluted, is that I had a scraping script here, which basically went through the site that these graphs are on, which is called ASPO France. I'll show you what it looks like. And I'm just focusing on Jean Laharre's papers. The reason for that is my father's working on a book with him, and so it's very useful to be able to find his graphs out of the myriad papers that you've done. As you can see here, there's loads of them. And so basically what the scraping script does is it starts at this page, and it goes through each of the pages at the bottom here, and it goes on all of the next pages. You can see I do scrape page article URLs, which if we go up, this looks over the page, as long as it exists, and then it finds all the article tags, because I haven't done a huge amount of web scraping, but I think I'm sort of getting used to it. If you inspect these, you can see that each one of these links to either a PDF or a bunch of PDFs is has an article tag in it, which then has a link to that. So if you look at this, and then on this page, it then has a link to a PDF. So you can see the télécharger. Right. So what I do is I find all the article tags on the first page, and then I pass those back, and then you iterate through all of the and the other thing is, I can't remember where I do this, but you end up getting multiple copies of the same PDF. I can't remember where I did this, but if I remember correctly, you can turn it into a set. Do that. Ah, yes. And the nice thing about that is that it's always unique. So by turning it into a set, you can get rid of all the duplicates, which is good. Anyway, and then we go through all of those PDF links, and then we just download them. So that's the scraping, and then we just stick them in a folder. And then to do the processing was originally separate. I've now integrated it, but you can see here in the main, what I do is I'd have a directory where all of the PDF files were, and then get all of the PDF files, and then I just have this function called process doc, which is nice, and you don't have to worry about that. But basically, I think that was to do with what I was doing later. But basically, we pass in the name of the document here, and if we do the name, we turn it into a path, and if it's a path, we just stick with that. And then because we have to process the pages, but we have to do both drawings and rasters, which is just images that are basically pixels. So these drawings are made up of instructions on how to draw it. There's this very good article about PDF parsing, and it says here the instructions. So where is it? For a table. I missed it. Ah, here. So this is drawing a table that looks something a bit like that, and you can see that in order to draw a rectangle, it gives a bunch of coordinates as operands, and then it draws individual lines and things like that. So that is how all of these graphs are drawn. So for example, it has a text box which it sticks up there, and then it has a rectangle, and it draws lines and stuff like that. So it's almost, the PDF is almost like an interpreted language, which the PDF viewer renderer looks through and then updates the state of where things are, and then displays that. So that's one thing to get out, but then there are also images, for example, which is not terribly high resolution image of Mauna Loa CO2 and various other things, and we want to get those out as well. So we need to do images and the drawing separately. Well, we don't need to do them separately because of that. I tried doing them both at the same time, but the problem that I found is that something in the state of the pages would get corrupted, and so it just wouldn't work. It's one of those very frustrating things that I did the drawings on their own and I did the rasters on their own, and they both worked beautifully, put them together and all crashed, which wasn't very much fun. So I'm doing them separately. So in order to do that, I have a process pages function which takes the path to the document, because they each need to open the document individually. Can't show the same one, and it just makes sure all the folders are there. And then what it does is it just runs the function provided on each page in the document. And so then what I can do is I create separate functions for processing the rasters and processing the drawings. So as you can see, the process drawing one is a bit convoluted. There's probably a better way to do it, but as I say, I couldn't figure it out. So in the rasters is fairly simple. There's just a get images function. I'm using a library called, what's it called? Is that Fits? Yes, which is, I think, Mu PDF. It's very confusing because the thing you install with pip and the thing you import are completely different names. But yes, Fits is the I can see Fits all over. Is the library that does the PDF parsing. So and then on a document, or on a page rather, it has a method which is get images, which gives you the image, but it gives you sort of a PDF version of an image which you can't export. So, or maybe you can, I couldn't figure out how to do it. So what I ended up doing is that in order to export the image, once I know where it is, you set the crop box of the page, which is basically the part of the page that it renders. And then you turn the page into a pixmap, which is just an image, just exported as a PNG. And then I have this save info function which takes all of the stuff and writes it out into the... So you see, what I did is I made a folder for each paper, and then inside I had a folder for drawings and one for rasters. And there should be... that's why. This is the new version there. Let me just put it up. But there was text as well I saved out because I didn't interface directly with the database. So let me show you that. So here we have in the out, for each drawing we have the image text, which is the text that's on the graph basically, the text on the whole page and the image itself. And for the rasters we just have the page text and the images, which you can see there is one of those annoying images, right? Don't need that anymore. Right, okay, so save that out. And so that's how the images work, which is fairly straightforward. It's a bit kludgy. But the drawings are more complex. So let me see if I can do a diagram. Let me just... Always incredibly prepared. Just give me a moment. So and then right. Here we are. Excellent. So what the code basically does is it looks at all of the draw instructions, which you just get. There's just like there's a get images method. There's just a get drawings method, and it goes over the instructions and basically looks at the first one and gets the first point there, which might be up here, or I don't know, might be, let's say it's at the corner of this box. Let's say, for example's sake, it starts there. So it then creates a rectangle at that point with all 4 vertices at that point. And then it goes again over this time over the whole list of drawings on the page. And for each drawing, it expands the rectangle so it includes the new point. So for example, let's say the next point was this one here. We would expand the rectangle so it now was like this. And let's say the next point was this corner here. It would expand it like this. And if the next point was over here, it would expand it like this. And basically the hope is we can then crop it in on the graph and not get the text. But the problem with that is let's say there's another drawing, there's another bit of a graph over here. That's a graph. Let's do another one. So it would then expand to be up there, which is why if there are multiple graphs on the page that are drawn at the moment, it just includes all of them, and also for some reason randomly includes bits of text. Well, I'm not sure why it does that, but this is the basic principle for how I'm trying to extract these graphs. And then I do exactly the same trick that I did before, and I set the crop box. So we've got these two very similar loops, which I find annoying. But we go through, and each drawing has multiple items in it, which is a bit annoying. But we basically look at each of those, and we, depending on the different types that it could be, if it's a point, we set all of the coordinates of our bound, which is just starts as an empty rectangle object, to be at that point, and then we break, and because it's a loop inside a loop, we have to set this continue variable. And then if it's a rectangle, we just start with that rectangle, and if it's a quadrilateral, we just pick the upper left-hand corner XY coordinate and just start with that, which is fairly straightforward, I think, if rather convoluted. It's a bit confusing. But then we do the same loop again, but this time we just use the include point methods. So if it's a point, we include the point. If it's a rect, we include that rect. And if it's a quadrilateral, we have to include all 4 corner points. So that is the basic idea, and then it does basically the same thing with the crop box. So the problem with that is getting it into the database if I did it this way, because what I would end up with, as you could see before, is just a massive bunch of files. And so in order to get it into the database, I wrote a PHP script, because I had more experience dealing with the database in PHP, which basically looks through a directory, picks up all of the folders for the PDFs, then it basically looks down in that tree and then adds them all into a database, as you can see here. And I've got this add entry function which takes all of the things that I want to put into the database, then it executes them. The problem with that is if you want to add other things to the database, it's very difficult because, well, you either have to write another file if you want to put extra metadata in, or you need to put it in the title of the PDF and or in the name of the folder rather. It all just gets very clutchy. So what I have done is I've changed the Python, so it basically does all of the same stuff except Python puts it into the database. So I've used there's DB utils. Here. I've used the MySQL connector library to add stuff everything to the databases. I could probably pass in a dictionary or something like that, but that works. But basically, I do the same thing, except in my loop, I download each paper, and then I do all the processing on it, put it into the database, then I go for the next paper, download that, etc. So one of the things that really hits with doing it this way is, though I suppose I still could do the scraping separately, but it's nice, and so I could do a command line thing where you could separate them, but you really get hit by the fact this is all happening synchronously. So it downloads all of the files. Well, it downloads a file and then has to wait for that before it can do anything else. And I have done quite a bit with Python async, but I do not like it. And as you can see in my PyJump video that I made a little while back, trying to make a WebSocket jump server to replace port forwarding, because that is very flaky. I'm not a huge fan of async IO, and sometimes I just cannot get it to do what I want it to do. So that's another reason why I want to move to somewhere where you can do, where that's easier. There might be an easy way to do it in Python, but if I do it in Rust, I can just should just be able to do Rayon and do a parallel iteration. I looked into doing it in Julia because that's another language I'm very interested in, but as far as I can tell, it has pretty poor PDF support. I found 1 or 2 libraries that haven't had a commit in 9 months, so it's a bit difficult, because I like the idea of Julia and it has lots of good things going for it, but I think Rust is the best option for now. So yes, basically this is the way it works. It scrapes them and then it parses them and puts them into the database. So what I want to do is to make a Rust program which can do these things, but separately, but well faster is the main thing. And when I was looking at it, if you remember this thing I showed before, is that in these instructions he was basically looking at the pattern of the instructions, and then figuring out based on where those are where the table was. In this case, is the point he was trying to scrape the names, the email addresses, and mobile phone numbers from the from this PDF list. So I was hoping that a similar thing could be done in this. So I but he's using the PDF library, and there are a few others which look quite good. They're at least seem to be the ones that I found at a much lower level than the Python ones, which is good and bad. Though, given the where is it? In the parsing, given what the information that we get about the drawings with the points and the rectangles and things, you might be able to do it, but but I'm not exactly sure how to do it. So the thing that I want to do first is to be able to see the instructions. So the thing I'm gonna try and do, see if I can do, is to see if I can just write a program, Rust program, that imports a PDF and just displays the instructions, or writes it to a file for now. So I think that's the plan. So I will make a project. Where are we? So, going to terminal. So, I'm never very good at inventive crate names. This is always the thing when you Rust coding through. I'm sure I can't. John would be better at this. So I've just called the Python PDF parsing. So graph parse, I think, would be right. Cargo run. And it works. Excellent. So let's open that up. In the VS Code. So what I'm gonna start using the PDF library, which is what Michael used in the article I was reading. I'll put that in the description in case anybody wants to read it, because it is very good. Though maybe it's just me, but I can't actually find the source code, which is rather frustrating, because I can't find where he actually brings in the PDF instructions. It's all about how to parse the PDF instructions when you actually have them. Maybe I missed the code when he does it in the file, but I've searched on his GitHub and I can't find it. So it's a bit frustrating, but this is what docs are for. Phrasing. Okay. There is also the There's another library called Low PDF, which is they both seem pretty actively maintained, so I'm not sure what the difference is. I will I think I'll try the try the PDF library. I think the Low PDF library might be more designed for PDF manipulation as opposed to parsing, but it's difficult to tell. And I think so. Can I just go cargo add PDF? Does that work? DVD. I think this was cargo, because I thought I heard that it was added to stable. So, because that would make life a lot easier. Let me start update. Let's see if that it's supposed to might be on the base channel. We'll see, but I think that would be would make it life easier. Right, so in the let's have a look at the does it work now? Rust up no, not rust up. Cargo add PDF. Woo! And it's working. Okay, that's excellent. Much easier. So in the this is the PDF library page. Where are you going? Oh no, I want you to. Right. So they seem to be slightly light on examples. Maybe that's just me. Might be interesting. So basically, what I was looking at is I think there was a document. Because they've got page builders and things like that. File. So how do you get you've got a page, so where do pages come from? So in the where have they got tests / files? No, those are just PDFs. So do they have in the test today. So there they have a file, and then the page tree. So that seems to be. Oh, I don't think that works because that's the right one. So, where are we? If we have a file, what do we then do as a file? Got a trailer. So, yeah, I'm not terribly sure about how to actually get stuff in. File, have we got some load, storage and trailer? I am pretty unsure of what to actually do. So I think it might be a good idea if we try the other one, which actually has a code example. The one thing that I found is that Rust documentation is very nice if you've already got your foot in the door, because and if it actually tells you what things do, because some of the things it it has all of the methods and has a nice little explanation and example, or even if it doesn't, you can tell by what the name is, and you can just look at the docs, and it's pretty, you can figure out how to do things. But it's a bit difficult when you can't even figure out how to open anything. So this is low PDF, which where are we? So was here we are. So here's the GitHub, and they have an example. So this that's creating a document. They've got merging, and did they have a modifying? They don't just have reading. I mean, it seems like a pretty obvious thing to want to do, because PDFs are pretty ubiquitous. Anyway, but here they've got use a document, and is that not a main function? I guess it could be. Anyway, so we create mutable document, so document load, and that makes sense. So let's just see if we can do that. So in our cargo.toml we can actually delete this because we don't need this, but I get a chance to use cargo add again, which is good. Is there a cargo remove? Maybe? Oh well. I'm good. Oh, it has a rayon feature. Might be interesting to look into that to see what kind of parallel stuff that you can do with it. So if we it's got both of them. So we don't need PDF. Excellent. So need to compile all of them. Doesn't seem too bad. Right. So then now we need a PDF file. So what I'm going to do is, I think this one is nice, but what I'm gonna do is I'm gonna print the first page. So then we only have one page to worry about. That seems to make a lot more sense. So print to PDF. Yes. Print. And then in with the code and graph parse. Graph graph.pdf. No point saying graph pdf.pdf. And who? That's not what was intended. Let us try again. Pages. I just want page 2. Yes. PDF. Print. Graph. Much better. I don't know why it didn't work before. Right. Okay. So. For this example to work, a parser feature needs to be enabled. So let's go back into main. Main function not found. Do you need to? Oh wait. So let's try. Does that work? A bit weird how it's all grayed out, but I guess because this is a code is inactive. Oh, right. I guess we need to enable them. So I haven't used features before. How do we? So how do we I've seen examples of it, but I'm not sure how to actually do it. Specifying dependencies. No, what's the? has to be a... I know you can do it, but how? So let's try all of the early version. All of the explanations seem to be about how to add it to your crate, not how to import features from somebody else's. Features. Oh, no. Features equals. And then I want the. So code selector. Non-parser and POM parser. So it says here that non-parser is, sorry, POM parser is there. Non-parser. Right. Does it work now? Does it work now? That should panic because there's no file called that. What if I comment this? Comment that out. Is that failed to resolve? Oh, I need to. So now if I that's bizarre. How do you disable? How do you enable them? A parser feature needs to be enabled. Well, let's see if it works anyway. So, I mean, do they have an example PDF? Let's see, example.pdf. No, they do not. So, I mean, let's just try graph.pdf, see if it I mean, that will probably panic because it's got the wrong. Well, it won't. It just won't. Is that actually gonna? Save. If I just minus. Oh. Let's try if true. Does that? Ah. Ooh. Invalid PDF structure. That is rather unhelpful. So I mean, let's just let's just try, since that isn't working. Let's try the one that just creates a normal PDF. Now this doesn't seem to have a main function, so let me just stick this in main. So let's see. Example.pdf. Oh, good. Okay, so something works. So let's see what this is actually doing. So we're creating a document type, which is, no, that's just, can you go to, we can have a look in I guess the document just represents a PDF in memory. So it has a version, trailer, reference table, objects, ID, bookmarks. So then we add pages ID. So my understanding is that, well, most things in a PDF have an object ID. So that's why the pages instead of page ID. But anyway. And then here we have the actually creating the content. So where's my table of PDF instructions? So BT is begin text. No, that's CPU instructions. What are they? PDF opcodes. Let's try that. I think I've finally found it. This is the Adobe reference, which is a PDF, funnily enough. So syntax. Character stats. Where do we actually have graphic? No. Okay, well, I'm assuming TF does something. Maybe it would be in the, so this is the operation. So we have new. Right, okay, that's not terribly helpful either. Anyway, so let's see. I do know that TD is move text position, and then TJ is show text. So obviously this will be the position. I suspect this will be the formatting, because because F1 here is the font that we have that's defined here, which is Courier. And then I'm assuming 48 is the size, because I'm starting to think maybe the PDF viewer in VS Code just... Oh, no, it just doesn't work. That's weird. Let me try running it again. Does it work now? Oh, it does work. Bizarre. Anyway, the text is big there. And then ET is end text. And then the rest of it seems like it's just basically squishing metadata together so we can then save it out. Compress it and save it out. Okay, so I guess that makes sense. But what we really want to do is to get instructions out. So what I'm going to do is look for the document. So what we want to do get objects. Seems like these would be interesting. Traverse objects. So that's from the trailer. So I'm not exactly sure what that is, but it says that gives the location of the cross-reference table and of certain special objects. The objects that make up the document contained in the file. Could we just go over the objects? What's object? I'm assuming it will be an enum of right. So get pages, so we could get the page content. Object ID of the page. So that seems like it might be useful. So if we do the page iter, I'm assuming that would give you an iterator over the pages. Oh, right. What's the difference between the content stream of object? Okay. And then we'd want to that's add decode text. That seems like it. Why don't we try decode text? So that just seems for So let's see on a page. Where are we? Where was the page iterator? So if we do get page contents, get, oh, that's right. Right. So is there a page struct of any kind? If so, how do you get one? Because that might. No, but I mean, it seems like everything is just an object ID. So what we, well, let's try the get page contents. So let me get rid of all of that. And so we want, we just need load PDF document for now. We want let doc equals document load, and then in this case it's just going to be the example broken yet? No. Well, let's just try example.pdf. Let's see if that works. God no. Oh. Right. Okay. Well, that seems fine. Which is good. So what I'm going to do is I'm going to do for page in doc dot, and then it was page iter. And then I'm gonna do print line. So, and I think this will just be an ID. No method found. Or result email. Oh, I need to unwrap this, that's why. Unwrap. Well, I suppose I could do expect I'll just unwrap it. I'm not good at error messages. Right, okay. Let's try this. So what this returns, page iter, is it's an object ID. Oh, and that consists of 2 numbers. Right, okay. Seems slightly strange, but I guess that's something to do with the way they've done it. Under the hood, I need to look closer at the specification, which is 756 pages long, which is not terribly appealing. Right, okay. So then what we can do is we can do doc.get decoded. I wonder. Well, let's just do get page contents and do page. And then let's do contents. And then So so is that that's just all of the IDs. So I suppose if we then get the page. So there's a get object. So why don't we try doc get object and then your page. Oh no, we want contents. The first thing on the page. Seems like it's a stream. So how do you actually get? So that's a stream, is the objects that's there, but that should just represent this, the text. So a stream has content. So why don't we try dot unwrap dot content. Well, what type is that? Is that a stream or is that something else? Stream and stream. What if we just no object? So it's an object. So how do we unwrap the object to get at the so if we do dot as stream dot unwrap again, then dot content. Let's try that. That's very helpful. So are some of those then opcodes, or are those? Because obviously hello world is not all that. So what is the stream actually? So let's try the get and decode. Get and decode page, and then really should write a function on a macro that's just isn't there a debug macro? remember reading that somewhere. Content. Right, just that. What's that going to do? Oh, that is much more helpful. That actually looks like what went in. So we have operation, operator, begin text. I'm assuming text format, text display, and text position. What to do? I don't know. Text stuff and end text. That seems like the one to use. What is that? Oh, no, I just want to get rid of that. Okay. That seems right, and let's is it debug, is that? Or is it prints and returns the value? Right. So does the macro returner? Oh right, that's a bit weird. So what does prints and returns the value? Oh, it returns it, right. Oh well. It seems like. And what does? Anyway, bit annoying that it does over so many lines, but that makes life a lot easier. So now, if we try instead of doing the example, if we do graph.pdf, this will be a lot more instruction. That's weird. Unwrap that. Is there just so on page does it go on any pages? How bizarre. So what happens if we try and so we get some stuff there. Why don't cross-reference table? Is there anything about the pages? There was where are we? There was a way of getting all the pages, wasn't there? No. Page. Try someone. There's adjust 0 pages. No. Get object page. Get pages. So doc get pages. Let's try that. See if that works. Huh? So why are there no? I mean that's a page. Anybody? Anything? Library for. That's the same examples. So. Where? Are there any issues on that? That is bizarre. Let's try Let's try this one, which has 26 pages, see if we can find any in there. Right. Right, well, it's certainly... So, now, can I... Because in here, the graph is on the second page, so that's what I care about. So, what I want is... what I will do is I will... Let me... add that, and then I'll say this is init with no pages apparent for graph.pdf even. Yeah, that's fine. Commit, save and commit. So then we'll publish that. Very exciting. So now let's change it to this. And what we want to do is we only care about one page for now. Ooh, no, I just want to go to this line. So we want to let page ID equal, and then this is going to doc.get pages. Actually, what I will do is I'll comment all of this out, so I just get that to make sure. So, what type is that? What does get pages actually return? Get pages, a binary tree map. So how do we get so where was it? Get pages, do the binary tree map between U32 and object IDs. So that's the page number and the object ID. So I'm assuming that's a binary tree. Yeah, binary search tree. So insert no, I haven't seen that bang before at the beginning. How do you define? So get, right, okay. So so let's try page ID. So just going to be that at the moment. So then I want get pages. Comment that out. Dot get 2. Need to do reference to 2. Temporary value dropped upwards. Oh, do you? I haven't seen that before. Page ID. Oh, because that just does that just return a reference? Where's get? So if so get returns an option to a it returns an option to a reference. So, and that is to right, and that because that binary tree map is a is an owned value. So basically what get gives us is a reference into that. And because this value gets dropped at the end, then that reference lives too long. So is there a get owned? I guess we could, would that work? No. Oh, you need to do .unwrap, wouldn't you? Right, okay. But I'll just do and then just do pages, and then I don't need the clone. Excellent. Good. So now, oh yes, because that's the right. I see. Yes, that makes sense. So that is an ID. It's not page left and ID 0, because yeah, the ID is 2 numbers again, which is I find a bit weird, but yes, that's good. Right. So now we page ID. Found. Why does it need an owned object ID? Get and decode page content. That seems a bit weird. It's just an ID. Why does it need to consume it? So I guess I do need to clone it here. Seems a bit weird to me, but c'est la vie. So so now that looks pretty good. So now what I want to do is I want to try and print that out like this is printed. So like this is printed. So if I guess what I'll do is I'll just write the code, then a colon, then the operation, colon, operands, new line, and repeat. So let's try this on, and again on graphs. I do find that very bizarre. You see now online. Oh, it's panic on that because there's no truth. That's very bizarre. Anyway, if we go back to example, is example broken now? No. On a none value. Oh, it's because it doesn't have a page 2. That's why. Okay, let's have a look at the first page. Excellent. So what we then want to do, I need more. So we would then want to, so this content is of, let's see. So get and decode page content returns a content which just contains operations. So decode. So is that an iterator? Is this? Clone. That returns. How do you actually get the operations out? Format. Oh well, how does do it when it formats it? So where's format? The thing I don't get is that it doesn't have. So there's a new. Where is operation? Can you just do? I guess in the operations you can. Where's this? Operations. No. Where's the? Oh no. So. Right. So that's a vector of operation, right? So you can. You can iterate over that, right? So we want to do content dot operations. That should basically be the same thing. Good, with some square brackets for added flair, which is always fun. So then let's do for operation in content dot operations dot iter, because just need, it's all immutable anyway. So though that is owned, so I guess if we need to do it anyway, it's fine. So let's just do let's just print the operation. Don't want that. Excellent. So so then if we is there a way to write by so this seems like right. So if we okay, well let's try that. So if we this so you do. Right. So and now we can do that, can't we? Can we not? Oh, right. Because we have what's happening? And then if we excellent. I very much like the question mark operator. Can only be used on results and options. So you need to unwrap it, but you can't use the question mark. Not exactly sure why. Anyway, so now we have all of the operations. So let's try cargo add line writer. Oh, what's it actually? Is it called something else when you what's it? How do you actually Oh, is that in Oh, it's in the standard library, that's why. Right, so let's just bring all that stuff in. Okay. So here we would want to do let file equals file create and then operations.txt. That makes sense. And then we shadow that with a line writer. Line writer, new file. Okay, so then for the I had to run. So for that's empty. Now if we do it again, so I'm just curious because I don't know whether it will so if I do file dot so that's that formatted. That would be neat. I'll look at that in a minute. We'll just do write all, and then test string. Right, and then if we run it again, does it append or overwrite? I think it overwrites. Okay, which is fine for now. I wonder why it does that instead of. Does it matter? Well, it seemed to work just fine without the new line character, but so then if I just do that, does it? Then it doesn't. So yes, it definitely is rewriting file every time. So it's fine. We don't need that. So what? Basically, then we want to find the operation. How do we? There's just operation operands. So let me see what the right format. Line writer, and then we want. Where's the right? Oh. So what does the right format look like? Because that seems like it would be. And let's see what the point of that is, because if we just do file dot write all and then do format and then dot as bytes. Just put a semicolon there, and then this is going to be. So we want the operation dot operator and the operation dot operands. Does that work? We need that, and we'll put a question mark on there, and then we'll do file dot flush to make sure everything gets put in. I'll put a question mark on there as well. And says it writes by line, but it doesn't actually put a new line character in. I guess you have to do that. seems that's fine. I just need to put a new line character in here. Then run it again. And we see all of our operations. I suppose we could do if we do let operands could you, because if I guess no, just let operands equal operation dot operands, and we'll do if operands not equal. Oh, it's a vector, so really we want vec. Then we want operands, else we want empty string. Does it need to be like what's the not equal operator? No. Too many different languages. That's it. Binary operation. That's very strange. Oh. There's still ways. Binary operation. Why is it binary? Is that just means it takes two arguments? Anyway. Just get rid of that. That's unnecessary. And it doesn't work anyway. You'd need to do a bunch more stuff. Right. Happy now? Indeed it is. So that seems useful. The only problem is finding out what these blasted codes actually mean. So now we can try JHL test 1, and this should then rather certainly a lot more stuff. In the was it actually, I don't remember whether it was actually readable in this version. Yes, you could just see it says hello world. So if we look at this cover page, so it's got language tags, that's useful. It's a text things that doesn't seem to have any, or can it not, does it not does the library not decode stuff if it's French? There doesn't seem to be very many Strange, it seems to be very different from the other one. Let's try looking at where are we? Page 2. So this will somewhere have the drawing instructions in. Really would be useful. Problem is, if you just look up PDF operations, you get PDF documents of things. Yeah, you get a PDF of operation codes for other things. Tried operations. So does it act, so if we go into the drawings, because that's what I'm most interested in, syntax, just looking to see if we, these are all the character sets and things, escape characters. So there also might be something that to get them out based on the stream and the object markers. I mean, at least in this case, it all depends on how they've been exported from Excel, which is where, and Word, which is where they originate. So going back to that view might be helpful, looking at the objects. As I say, it would be really nice to find a table of what the blasted codes mean. Entry, NAS, encryption. Is there a table of contents? Where are we? We're in 7 in syntax. In the graphics, do they have anything? So if we find op reports, anything? No, that doesn't seem like it's notation. PDF operators. Well, what are the PDF operators? So what if we put PDF in front? Ooh, right, okay. So general graphics state, this one's, so text objects, There's begin text and end text, and then the other ones are the text state and text positioning. That makes sense. Text showing. Okay, so then our graphics states are those ones there. Oh no, that's just color operators. But because they have color operators here. Do they have graphics operators? Do they? Okay, so because basically I have another look for tools, but one of the main problems at the moment is finding, well, basically to visualize or understand the way that PDFs are generated and the way that they're generated by Word from Excel. Because that's really the key factor. So it might be interesting to go back to the document, because the easiest thing would be if this was all in one object or reference tag, but then identifying what it was might be trickier. But if it were, then you could just check what kind of instructions were in it, and if it had graphics instructions in, then that would be it. Then you would use that. I suppose, don't want to get ahead of myself, but the other question is, how do you, even if you did find it, how do you actually print it? Is there a, let's see, because on the Python version, one of the key things was exporting it as a bitmap. So is there, if we do the where are we? So is there any way of actually exporting this? Or there's not many things, so I don't think I saw that's adding a graphics state, but I don't think how do you actually so we can save it, but how do you print it? I think it said something about, it doesn't seem to be say anything about how to get an image out of it, which is annoying. I remember on the if we on the first library. Oh, it's just called. Where are we? This one mentioned Pathfinder for rendering libraries. So, but then how would you get the then the question is getting the information from whatever's doing the parsing and finding into, if we're using this to, if you use this to export it, how would you do that? Because there doesn't seem to be there's PDF render here, but I don't know. That's experimental, so I don't know if that would be worth trying. So because it seems like what I might have to do is, if I found the sort of the area of where the graph was and I wanted to export that, then I would have to sort of store those coordinates somewhere, open the PDF in something else, and then crop it and export it. Which, I mean, you could do, because if you stored a vector or something, if you could have each page number or the page ID and then the coordinates, and then so you could only do 2 passes, but that still seems like a very inelegant way to do it. I don't know if given that, it might be thing about most of these libraries, they seem a lot more narrow and low level than the Python libraries, which is very frustrating. But it might be worth investigating whether the graphs are actually in sort of separate stream things. So if I, or objects, because if I go back to here, if we, so I remember let me just comment that out for now. When we had the dot page iter, can I do PID? I mean, it's a lot easier, though obviously another process. So, so then if we just do the, which one was it? Get content. Was it get content? Where was it? Oh yeah, get page contents, right. So there's get page content, which does that, the get page contents does the string, right. So then if we, all right, so we don't want that. Let's see. We still want this because we only care about that one page. So if we then do let content streams, or just stream equals dot get page contents, and then the page ID, and then let's try content stream. So let's see what that looks like. So that's page 2, which is, just page 2 so it doesn't get overwritten. So is all of that just in one stream? So what's this? If we look in here, we have these spans. Are any of them? They all just say ang. They all just have the language, so that does not seem particularly helpful. But is there anything then? And is it confusing that there's content and contents? So then in the content, right, that's just a bunch of unintelligible gibberish, seems like. Let's stick with the content. So then what is the page ID? So there's difference. So it seems a bit weird that you have a page ID that only includes for one other thing. So we have a page ID, right? But if we have an object ID, what can we get from that? If we do the that's just 0. just get the first ID out of that, and then we want to do doc dot get object. So then that's this stream. So then does that correspond in some way with this? Should be the same thing. But what is the get object returns? Well, we could just do a question mark there. Get an object ID. Ooh, no. But you give it an ID and it just gives you another ID. Oh no, that's an object type. So what? So right, and then this is the one that's I remember we did this before. So then as stream, and then that seems to give you almost exactly the same thing as dot get page content of page ID. Where are we? Oh. One seems to have a lot more stuff than the other, but I'm not exactly sure why. Fortunately, that seems minimal utility. So, I suppose the thing that we can do is we can have, at least in here, if we look, where did it say? If we go back to PDF operators, they do have this list of what operators start with what. So I think for the graphs, oh, they say they've got. Oh, I should have looked more closely. They have. Okay, so. Right, if we go back here. 57, 59. Right, so at some point I should. Irony is, if you wanted to get all of these operators out, you'd have to write a PDF parsing program to identify that table and get the stuff out of it. So Q saves the current graphic state. Capital Q. So, and then if we look on path construction, I think is probably going to be something that we 59. Right, so so I suspect we're gonna see some of those. So if we look for the, well, Q seems like one that comes up a lot. Seeing it's almost always. Not sure what the. I must do something, but what's the point of capital Q, lower Q, upper Q, upper Q? I don't know. There's probably a reason. Because. So lower Q saves the current graphic state, and then upper Q restore the graphic state by removing the most recently saved state from the stack and making it the current state. So what's the point of... So you're effectively popping and pushing from the stack, so what's the point of popping from the stack and then immediately pushing? I'm not sure. Or maybe you take the old state on and then it disappears, so you want to put it back on to keep it as a record, I guess. I don't know, it seems a bit bizarre to me. But the problem is that, okay, so that one's happening all the time. So what if we look at the what were the ones that... So if we have the RE is the rectangle one, that's also all over the place. I mean, it's absolutely continuous. That's very annoying. Because at this point, I can get the rectangle operations. So and other graphics instructions. I think I could pretty much replicate finding the position like I did in Python, the method I did before. But I'm still not sure how you'd actually export the stuff. So what about capital S, which is stroke? How do you make it case sensitive? No actual operations there. What about L? I am not sure. It seems... Seems like there really ought to be some way to separate the graphs up, but how to do it, I am not sure. So I will think about it. So I'll also have a look if there are any other libraries for Rust or Go, or I looked into Julios, I think I said before, and I really couldn't find much. but I mean, there must be a better way to do it. And I mean, I'm pretty sure in Python, because you can, if there is a pattern to how they're exported. So one thing I might do in the next stream is just export some sample PDFs from Word with some graphs from Excel, and trying to figure out how it actually renders it, because obviously it is an open source, so you can't just go and look. Not that I'd necessarily be able to make heads or tails of it anyway. But yeah, so I think that's the plan. It's quite frustrating. I might I might also do some I'll probably keep going on the compactor project and some other slightly simpler ones, and also interested just in general in doing some work on Julia and maybe Go, so I might make some language learning streams as well as looking at my some AI projects. So yeah, well, I hope anybody who's made it this far after 2.5 hours has enjoyed it. I've found it quite frustrating. It seems like PDFs that's one of the things I think Python has good support for. The problem is that just actually doing the parsing takes a long time. I mean, just for now, in this sort of limit, even not a huge number of papers, but I've already parsing 200, and it takes about 15 or 20 minutes. I mean, which isn't terrible, but if you're gonna, if you want to do 1,000, 5,000 papers, let's say you wanted to, scrape a bunch of papers off of archive, you could easily get tens of thousands of papers, and it would just take hours. So, and also part of my idea is that if you upload things to the website, and then it would parse them automatically, and some of the larger papers is just looking at it, and it sometimes it takes 20-30 seconds to parse one file, which would be a terrible UX. So I think certainly I need to do something. I might also look into Python and other sort of ways to speed up Python, but I think also it really needs to be done asynchronously. I might have another go at async.io, but I'd really rather do it in another language. Python has its things it's good at, but I've end up with lots of weird errors in Python that I don't when I get in Rust. At least I get errors in Rust usually when I'm writing it, and not 3 days later randomly breaking. It's a very fun thing when I was actually doing it. I started getting seg faults for reasons I have no idea why in Python. But anyway, so I think that's it for today. Hopefully there'll be something else soon, because I really want to actually solve this, be a stream on this, and other stuff coming up. So see you then.